Lesson 4.1 will cover lesson 25 worksheet. We're going to multiply monomials today. A monomial is basically any number, variable, or it can be a product of a number and one or more variables. So a product, again, meaning multiplication. A constant is a monomial that is a real number. Determine whether each expression is a monomial, right? Yes or no, explain your reasoning. So example 1, identify if it's a monomial or not, and you would state here, yes, this is a monomial because it is a constant. 23 is a real number, it is a constant. Example B, f plus 23. This operation that you have here is not a product. So addition is happening here, so no, there is addition. So we have more than one term. So more than one term there, it would not be a monomial, mono meaning one. Down below, I'm going to let you go ahead and go through these. You need to determine if they're monomials or not, and then go ahead and list your reasoning. So you can kind of pause the video here and give it a shot. I will let you know that D and F will be a little bit tricky for you. Now that we're back here, C, you should have stated in C that it is not a monomial, because again, you have addition, there's more than one term there. D actually right here, it is a product. Right there, it is a product of variables, and you're dividing by a constant. When you're dividing by a constant, it can be a monomial. E should be pretty self-explanatory. Again, it is a product of numbers and variables, so yes, it is a monomial. And the last one is actually not a monomial, okay, because you have a variable as a denominator. So when you have a variable in that denominator, it's not. When you have a constant in the denominator, it is a monomial. The first rule that we're going to talk about, and this should be a little review from last year, but however, problem's a little more challenging, is the product of powers rule. Product of powers rule basically says to multiply powers with the same base, and you have to have the same base. When they have the same base, you add the exponents. And they give us an example here. Notice algebraically, x is our base. When it's the base and it is a product, meaning multiply, you add your exponents, so m and n. Same situation here, same base of 4. 4 and 4, well, our exponents when multiplied, 2 and 3, we add them together and we get 4 to the 5th power. First example, you have a product of powers. Looking at this problem here, 5 and 2 are not the same base, so you go ahead and carry out that operation there. 5 times 2. Everything is being multiplied here. What has the same base is r. Okay, r has an exponent of 3 here, r has an exponent of 7 there. So you would add your exponents when it has the same base. 5 times 2 giving us 10, and r to the 10th power. Same base, add the exponents. Next example here, 3. Now there's no coefficient in that second grouping, so it really has a coefficient of 1. So it's really saying 3 times 1. Next thing that you need to look for is things that have the same base. Well, here's a c, and that really has an exponent of 1, and here's a c to the 4th power. Same base being multiplied, add the exponents. D has an exponent of 2, exponent of 3, again being multiplied, add the exponents. We wind up with 3, c to the 5th, d to the 5th. Go ahead and give the two problems below the skills check a shot. Pause the video and we'll come back. Now that we're back here, we can see that this is what our first step would be. Multiply our coefficients, add the exponents for z because it's being multiplied. You should have wound up with 21z to the 9th. In D, Here's what we have. Coefficients -4, -5. Our same bases A, B, and C being multiplied. Add our exponents. In question D, you should have wound up with 20, A to the 6th, B to the 4th, C to the 3rd. Next rule we're going to cover is power to a power rule. Basically what this says is when you have a power raised to another power, you multiply your exponents. As here, you have 5 to the 2nd, it's raised to the 3rd power. When you have that power to a power, you multiply those together. So we get 5 to the 6th power. So our first example, we have 3 to the 2nd raised to the 3rd power. Again, you have power to power. So you multiply, and you wind up with 3 to the 6th power. If it says you can leave it as an exponent, you can leave it as 3 to the 6th. If it says to simplify, we would have to simplify that, and we'd wind up with 729. Next one, look here, we have 2 to the 2nd power. It's raised to a power to a power. When you have power to power, you multiply, so we need to multiply those out. We get 2 to the 24th. Again, simplified, we can simplify this here, and this is what we would wind up with after we figure out 2 to the 24th power. Again, go ahead, pause the video here, work through C, check back in. Alright, again, power to power is how we'd set it up. You better hang tight here, that doesn't mean you can go home yet. 2 to the 2nd times 2 times 4. We wind up with 2 to the 16th, and we can go ahead and simplify that. 2 to the 16th would give us 65,536. Using product of powers and power to power, we're going to go ahead and simplify a few expressions here. So we're going to go ahead and work these out. Example A, we are multiplying these two monomials together. First thing that I would tackle is this right here. We have 4, and now 4 really has an exponent of 1, x really has an exponent of 1, y has an exponent of 3, and notice it's raised to the 2nd power. Power to power says we go ahead and multiply, so we have 4 to the 1st times the 2nd power. We have x to the 1st times the 2nd power. We have y to the 3rd times the 2nd power. So this is basically our first step. Second is I'm going to go ahead and take this other monomial here, and this is being multiplied. This has a power of 1, and y has a power of 1. So we have -2 to the 1st. Notice it's raised to the 2nd power, and it's also raised again to the 3rd. So that's what it would look like. Y, same concept. Y has an exponent of 1, raised to the 2nd, raised to the 3rd. Go ahead and multiply things out. We have 4 to the 2nd power, x to the 2nd power, y to the 6th. Next group we have -2 to the 6th power and y to the 6th power. Simplify here. We have 4 to the 2nd power is 16, x to the 2nd, y to the 6th. We have -2 to the 6th power, which is going to give us 64, y to the 6th. Now the next piece here is we need to go ahead and multiply these numbers together, because everything is being multiplied together. We would wind up with 1,220 or 1,024. We have x to the 2nd power. Notice there's no x to the 2nd power over here, so we just drop in x to the 2nd power. Now we have y to the 6th and y to the 6th. When they have the same base and they're being multiplied, you add the exponents. So we would end up with y to the 12th. Here's our answer for A, 1,024, x to the 2nd, y to the 12th. B, we have an area of a circle. Area of a circle is pi r squared. Well, they give us the radius. The radius is 2ab to the 2nd power. So I'm going to go ahead and write out the equation for area of a circle. So that equation is A equals pi r squared. I'm going to go ahead and use substitution. Substitute in for r, because we know r. R is 2ab squared, and we still have this square on the outside. So next part is go ahead and keep simplifying your problem down, and we have, here's the power to a power. Well, we really have 2 to the first, right, times 2, a to the first times 2, b to the second times 2. Now we've got rid of that power there. We find out that the area equals pi 2 to the second, a to the second, b to the fourth. Still can simplify. We know that 2 to the second is 4, a to the second, b to the fourth. And we couldn't simplify anything from there. We're going to go ahead and leave that answer. We don't need to multiply pi times 4 because then we would end up rounding. So this actually, the area right there is exact. The only thing that we need, since it's area, is that it would be square units being an area. Go ahead, pause that video now and give example B a shot here, and then we'll check back in. Alright, here in B, we go ahead. This is what the first step that we should have done is that we have raised to the third power. So I've raised everything to the third power, and here I have a power to a power. So I've raised everything to those two powers. Keep simplifying your work here. We have negative 2 to the third, a to the sixth, b to the sixth, negative 4 to the fourth, b to the fourth. Simplify again. Negative 2 to the third power is negative 8. And then we have negative 4 to the fourth is 256. Next step, I would go ahead and multiply those two numbers there, and that should give us a negative outcome. When I multiply them together, I get negative 2048. Now I just go ahead and I'm going to drop a to the sixth in there because there's no a to the sixth on the other side. Now I have b to the sixth and b to the fourth. Multiplying, same base, add the exponents as we did there. We should wind up with an answer of negative 2048 a to the sixth, b to the 10th. This concludes 4-1 multiplying polynomials, or multiplying monomials, lesson 25 worksheet.